In this video, we'll be looking at multiplying and dividing rational expressions. Now remember that a rational expression is, on a basic level, a fraction that has a polynomial in the numerator and denominator. So if we're going to multiply and divide rational expressions, again, it's going to be exactly like with fractions. So remember, when you're multiplying fractions together, you multiply the numerators and then you multiply the denominators. You always want to reduce your answers as well, just like how we were reducing rational expressions yesterday. So if I give the example of, let's say, 3/4 times 1 over 2, all I have to do here is multiply the numerators. 3 times 1 is 3. 4 times 2, multiply the denominators, is 8. So 3/4 times a half is 3/8. Now, you should always look at your final answer with fractions and also with rational expressions to see if you can reduce it. We can't reduce this one. Now, if we are dividing, one small change, let's say that I write out 3/4 divided by 1 over 2. What we want to do is we want to inverse the second fraction and then multiply. Just remember that division and multiplication are opposites, or they are inverses. So instead of 3/4 divided by a half, I'm going to write that instead as 3/4 times. Now I'm going to flip the 1 over 2, or inverse it, and make it 2 over 1. Now, typically we wouldn't write 2 over 1, but just for demonstration purposes, I am. Now I can multiply. 3 times 2 is 6. 4 times 1 is 4, so 6 over 4. Now this one we can reduce, and we could show it, but we know that 6 over 4 is 3 over 2. So for multiplication, multiply the numerators, multiply the denominators. For division, all you have to remember is to inverse the second fraction, and then you can multiply. So it turns out the same thing can be done with rational expressions because they're basically fractions. Now, step 1, I would always recommend that you simplify both expressions first. This is going to make your life a lot easier, and if you deal with something that's reduced, yeah, it's going to be a lot easier for you. Now, after you simplify, then you can multiply them together, just like I showed you. But then you always want to simplify your final result by dividing out any common factors. So just like our lesson yesterday, that's going to be a part of every single question. Now, a very basic example here. Now, these two are basically two fractions. So v over 6a squared times 3 over 5v. Now, what I'm going to do, I'm going to take a look at each one separately. V over 6a squared, there's no common factors there, nothing I can simplify. Same thing with 3 over 5v, nothing I can simplify, so I'm going to go right into the multiplication. So multiplying the numerators, 3 times v would just be 3v, over, now when you're multiplying these terms together, so multiply coefficients, 6 times 5 is 30. Then we have a squared and v. All right, so now that's my answer, but just like with fractions, we always want to reduce as much as we can. So I'm going to find a common factor between the numerator and the denominator. Now, what they have in common is actually 3v. Now, in the numerator, 3v would leave me with just 1. I am going to show you that because most common mistake is people would think that you get 0 in the numerator if you cancel out that 3v, but you do get left with a 1. Now, in the denominator, if I take out 3v, I'd be left with 10a squared. Now, I'm going to continue my solution over here. What we know from yesterday is those two factors will divide out. So we are actually left with 1 over 10a squared. So the original question, when we multiply it, it is equivalent to 1 over 10a squared. Now, we are always going to state any restrictions on the variable. You can see from our last answer here that a cannot be equal to 0 at any point. What you have to remember is to check every single step, because we do have a v in the denominator in the second last step and in the original question as well. So this tells us that v can also not be equal to 0. That must be another restriction. We'll do this second example in class, but this one, example number 3, I'd like to take a look at this one. Now, both of these expressions are already simplified. You see that we have common factors here of 5 and 4 in this expression. And we also have p minus 10. Now, it's in brackets here for a reason. We'll see that a little bit later. But everything's already been simplified first, so there's nothing more I can do. Now, because I see division here, what I'm going to do is I'm going to rewrite that second expression. Now, let me just write the first one. I'm going to rewrite the second expression to make it multiplication. So it's not going to be 1 over p minus 10. It's going to be p minus 10 over 1. Now, what we can do here, just to make our lives a little bit easier, we could write out multiplied 5 times p minus 3 times p minus 10. We can multiply all of those together here. We can also show in the denominator 4 times p minus 10 times 1. Well, that multiplying by 1 won't really do anything. But what is going to happen? If you think about it, right away, we already have common factors of p minus 10 in the numerator and denominator. So those are going to divide out. So what are we left with here? We are just left with 5 times p minus 3 in the numerator over 4. So the p minus 10 again in the denominator is now gone. Now let's take a look at restrictions here. Even though there's no variables in the denominator, we always have to look at every single step. So in the first step, and in the original question as well, we had the binomial p minus 10. Now this would give us a restriction that p cannot be equal to positive 10. Otherwise, those denominators would be equal to 0. All right, so that's it for this video. We'll do the rest in class.